Okay, welcome to Technical Technician from Diagnation. Today's video is called Honda PCM Power and Logic with a little Ohm's Law. As you can look down at your schematic, you want to take a capture, take a snapshot, because it's real important. We're going to be looking at 8 channels. We've been looking at a few different things. One of the most important things is PCM power and how the power gets there, and the importance of looking at wiring diagrams to see how the power is fed. In a case like this, it can come through different sources. We got it first. I'll kind of pan into the diagram. It can go from the PGI main relay 1 on this Honda, powered all the time by fuse 8, down into the control side of this relay that's E7. There's its transistor down there. The transistor has got logic controlled by the PCM. Also, the ignition coil relay, powered by fuse 2, they also meet at a splice, and so the transistor E7 will latch closed, and it will ground both of those relays at the same time. And when the PGI main relay 1 latches, it feeds the crank sensor and it feeds the PCM at terminals A3 and A2, while when the ignition coil relay latches, it feeds the 4 ignition coils. I just drew that to indicate 4 coils. I didn't want to crowd up the schematic. Pin E9 is an ignition switch run feed on that part of the PCM. That does not go through a relay. That comes right through the ignition switch, equally as important. And then basically, when I talk about pin E7, that's the control. That sort of controls the relays when that transistor closes and grounds. As I just said, that latches both the relays. Believe it or not, that is also the volatile feed for the PCM's memory. I've checked the schematic and I couldn't find any other direct hot feed from the battery. That is the one. So that's important. That shouldn't open up, because if that opens up, you would get your fuel trims reset. You'd get your monitors going back to incomplete. So it's interesting the way Honda wires it. They don't have a dedicated hot feed, but it feeds the volatile memory through that terminal. So if fuse 8 should go open or intermittently break open, the PGI main relay won't latch, obviously, and there'll be no power to the crank sensor, no power to pins A3 and A2, and no power to the injectors. But the power from fuse 2 through the relay coil will get to pin E7, because it has two ways of getting there, obviously. When I talk about this, when I added a little Ohm's law to this video, I want to talk about the fact that I'm going to have current clamps on 3 different spots of this video. Now, I'm not saying that we always have to have this many current clamps. I just want to, sometimes it may be to our diagnostic advantage, but nonetheless, we're going to talk about Ohm's law playing out, and we won't have to really put resistances and do any create a circuit. We have a circuit in its natural state. You'll see the effect of Ohm's law, because we're going to be watching current flowing through that relay coil, which is PGI main 1. We have another current clamp on the relay coil for ignition coil relay, and then we have one, as you can see, it meets at that splice, and would be the current flowing through both those relay coils. So that's going to be the sum total of the current flowing through both the PGI main relay and the ignition coil relay. So it's going to be interesting. When you see it on the scope, it'll make more sense. The math will play out just like Ohm's law does, and it will be pretty interesting. Just something to bear in mind. As I talk about this video some more, I'm going to tell you about where each channel is. We're on 8 channels. Channel A is current ramping the PGI main 1 relay coil. Channel B red is current ramping the ignition coil relay at the relay. Channel C is right at that pin at the PCM at pin E7. That is the ground or the control on the PCM, where the driver is, right below it. You see where the PCM closes that driver, and that signal will go low when it's commanded to go low. Also, as you can see, I have a little bit of a dashed line And between there, you can see the little green spot. That's indicative of an open, or that's always as I use the word green crusties. When we use a lab scope, our test point is critical. So I'm going to actually scope that in two spots. You're going to see it at the PCM on the solid green line. Then above that, you see the green crusties. And above that is another, I'm going to move the test point before the green crusties. So you'll see the difference in our voltage patterns. This reel has a diagnostic advantage. Always be mindful of where you have your leads when you're scoping. So just bear that in mind. Let me see if there's anything else. I will shoot this in two parts, maybe three. So anyway, I will tell you when I'm signing off. I have about 6 or 7 scope captures of different situations of cranking, running with a blown fuse 8 or with a blown fuse 2. We'll see what the scope looks like there. So just I'm trying to think if there's anything else I want to speak before. Just as I said, take a snapshot of this and get it right beside you, because when you look at the scope patterns, this will make a lot of sense. The colors will all, on the scope screen, will all match to what you're looking at on your schematic. So anyway, I will be going to the scope. Let me get it here. And we'll start doing one screen at a time, and I'll explain. We'll kind of go through it. Let's see if we got a good... how's that? Let me get the scope going. I can do better. I'll get the scope, then I'll focus it. I'll go down to our captures. We got about okay. 263. Okay. This is our first one, and I'll explain this. Just want to make sure we got good camera work here. This is Pico 7, by the way. It's a newer beta software. I'm getting used to it, so it just kind of cool. It worked out for me with this computer because I had some computer issues this week, and I kind of was forced to use it, and I'm kind of glad because I kind of like it. And okay, here we go. We're looking at basically an off to cranking to running with our 8 channels. I'll kind of take them. First, I'll talk about the current first. As you look at your schematic, you see channel A has a current clamp around the PGI main coil, and that is our blue channel. So let's look at that right here. That's the current right here. Car's key on, and then the cranking, and then running right here. That is current flowing through that PGI main 1 relay coil, and only the coil. Okay, channel red is the current flowing through the ignition coil relay, and that is right here. We see key on, and we see cranking, and then running right here. And burgundy, that is our 8th channel, and that is current kind of flowing through. Actually, it's the current flowing through both those relay coils. So in essence, when we measure everything out here, when I talk about Ohm's law, the current flowing through the blue channel and the current flowing through the red channel, that's a parallel circuit now, as you can look at the schematic. The sum total of those two currents will equal the burgundy. So let's just kind of take it, we'll measure one channel at a time, and we'll get everything up on the board on the top where you can see the amount. Just want to say something here. I probably didn't do my perfect diligence of zeroing out these amp clamps. I'm using a bunch of amp clamps. Basically, for the sake of clarity and simplicity, I'm going to know the current flowing, I'm going to look at the delta. I'm going to look at the current from the top to the bottom, and you'll see it because Pico does a good job of kind of figuring out the current difference, and that would be the current flowing. So here we go. Right here. This is our blue channel. Let me get this. Okay, come on. A little bit of delay here. Okay, here. And here, that's our current flowing through the blue channel. Okay, that sum total will be about 68.7. Now that I'm using a micro clamp on that channel. That's an AEMC K100 clamp, and basically the comparison is millivolts equals milliamps. So I didn't custom probe that one, but it's a real accurate clamp. It's got a 4 amp range either way. So basically that would imply 68.76 milliamps because it's a 1-to-1 attenuation. So that's the clamp, the PGI main 1 clamp. Let's go to the red guy and I'll do the same thing. I'm gonna look at the delta, the difference in current from the top to the bottom. And right here, okay. Okay, and that delta is, you got a little thick line now. That has been filtered. The delta on red is 74 milliamps. Okay, now let's go to the burgundy. That is the current flowing through both those relay coils in unison at the same time. So let's see if we got a sum total. It's fairly close. We're not going to get it to the 10th of a milliamp, but we're going to be fairly close. So the Ohm's law is going to kind of prove out that our total 75 milliamps and 69 milliamps, if you add them together, we're about 142 milliamps. So you can see how it's interesting how Ohm's law just plays right out where on a parallel circuit, when you have resistances in parallel, that the sum total equals to the current flowing through the entire circuit, and that would be at burgundy. That's going into the PCM at pin E7. So just something to bear in mind there. I thought that was interesting, and that's why I added Ohm's law to the video. Anyway, okay, I'll get rid of this, and we look at our schematic, and channel C is green. That's the voltage control at pin E7. You can see how that. Let me try to get that a little clear. Okay, that is green. Okay, that is our green channel. That is our, right here is we're high. Okay, that means the voltage is there at the pin, and then we turn the key on and the relay closes. The relay at pin E7 closes and the voltage goes low, and you can see it low the rest of the way as the driver on pin E7 will close and control those relays. Now when you see PGI main 1 relay latch, okay, let's go to terminals, scope channel D and scope channel E. We got a yellow and a purple. Those are the feeds. That's the feed coming in after PGI main 1 relay closes, and that's a good strong feed at the PCM on terminals A2 and A3 as you look at your schematic. The gray channel is our ignition switch feed. That's a separate feed, just as important. That sort of wakes up the logic, and that is strong at. Let me get that. I'm sorry. That is pin. That is E9. Echo 9 is where the gray terminal, the gray scope channel is. That is our ignition feed coming off the ignition switch. The next channel, orange, is our crank sensor. I always had to add that because it's always a good kind of a validator. It's high priority. It's right there. You've seen that in my other videos. Cars starting to build up speed, and then the frequency gets more and more here. That is a good crank signal. And the final channel is, we've seen before, is the current going into terminal E9. That's the current clamp at that on the PCM side of that splice, where it will flow current flowing through both those relays, both the PGI main relay and the ignition coil relay. So basically we have our 8 channels, and we're looking at everything. We don't see any dropouts, and everything looks pretty good here. So let me go to the next video. I'm watching the time, and we'll take a look at okay. Okay, let's look at this one, and I'll once I see it, it'll come back to me, and I'll be able to talk about it better insight. We're hooked up in the same way. Our scope channels are all hooked up same, and here's our pattern, and okay. Okay. Okay, as I look at this, okay, as you look at your schematic, um, we can say that that fuse 8 is pulled out just by looking at this. I'm gonna deduce that when fuse 8 gets pulled out, which is powering the PGI main relay, what would happen is we look at our scope. Let's take a look at each channel. Fuse 8 gets pulled out, so there's no current flowing through the PGI main relay coil, and we can see that. Okay, hold on, my bad. I think this may be one of the ones I should have expunged, but no, well, let's think about it. Let's kind of challenge ourselves. I'm kind of lost. Let's kind of deduce what's happening here. I really don't know because I probably didn't mark it good, but let's look at everything. Now we're in a real live situation. With car's cranking because we can see the crank sensor going right there. That's a good looking crank sensor. Our ignition feed is good, okay? And I could truly tell you, I'm just like you, I'm just kind of figuring this out. Okay, we got a good ignition feed on the gray channel. That's strong. That's running. We're at 13 volts. Okay, let's kind of take the next channel. Okay, our purple is good. Let's see if our purple is. Okay, evidently the PGI main relay is being controlled. It is latched because we have power at purple. We have power at yellow too. So obviously we have current flowing through the relay coil for at least the PGI main relay. Let's see. Let's take a look at that current. Let's look at that current flowing through there. We know that's about 70 something. Okay, yeah, we've seen it before, 76, so that's a good amount. How about the red guy? And we'll see how much is flowing through red. Maybe there's nothing wrong with this. Well, we're going to determine that. The red guy's about 71, which is normal. That's good. So that relay's got power. This may be a normal circuit functioning properly. And I can tell you, right, the reason it kind of slid me is the green guy. Let me see, the green guy looks low, and right there on the top of the channel, see the green guy? I think it just turned the key on, and basically that was a key on, and it was maintaining low because that relay, one thing about the PGI main relay is on a Honda, when you shut the key off, it stays engaged for about 30 seconds after shutdown. So nonetheless, we have current flowing through the PGI main 1 and the ignition coil relay. So our sum total current should be the sum total of both those if our burgundy will line up. So I'm going to roll the cursor down to burgundy and take this down, and this should be okay. All right, remember I got a little high there because I didn't zero it, so I want to get the delta, and that should be the sum total. Okay. 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 One thing. Okay, I'll close this capture out. Okay, this circuit is on. Okay, right here, we have current flowing here. So I probably had the key on, and current was flowing through the. I think I know what's going on here. Current's upside down, probably early into the video. Okay. Okay. All right. No, what happened here? Okay. I'm gonna get out of here and end this video called part 1. I'll be back with a better screen. I think I might have had a battery issue or something with that burgundy clamp. Nonetheless, signing off, and I'll be back for part 2. Thanks.